Hello to everyone! Today we will present you the Fibonacci succession, boldly named by some people Fibonacci series. So this is correct, and this is no. But well, let's start with this. Do you imagine a succession that can describe the universe with only a little formula? Well, that's a Fibonacci succession, a succession of numbers that is formed by only one formula. Well, before to start explaining how is formed the Fibonacci succession, I will show you some interesting facts that are probably interesting, like why Fibonacci do this succession, or what is the real name of Fibonacci? Well, the answer for these two questions is his real name is son of Fibonacci, and the second is because he had a problem that says a certain man put a pair of rabbits in a place around all sides by the wall. How many pairs of rabbits can be produced from that pair in a year? If it's supposed that every month each pair begets a new pair which from the second month becomes productive. So Fibonacci started to do some hypotheses and math series, and at the end he does his own succession with two numbers that are 0 and 2. So I will explain you the little secret of the succession of the first 20 numbers. So well, let's start. The first thing that you need to do is to put the first two numbers by default in the sequences. That are the 0 and the 1. 0 and the 1. And then you need to add both of them. And the result of add 0 plus 1 is 1. This one will be the next number in this section. So what the little law in the Fibonacci succession is that the final two numbers that you have in the succession, you need to add both of them to have the next number in the succession. So now I have this one and this one. What I need to do is to add both of them. So 1 plus 1 is 2. So 2. There's the 2. And then I need to add the final two numbers that are 1 and 2. So I add them and the result is 3. The number 3. So I will show you the first 20 numbers of this succession. There are 3, 5, 8, 13, the 13, the 21. I will put little comments between the numbers. 21, then 34, then 55. It's a little kind of difficult because I'm recording with the camera of my computer and I need to try to flip it just like this because you need to see it in the right way. So for me there are flip it. 89, then 144, then 233, then 377, 610, comma 987. I'm preparing I really am regretting it because I have all of them in this like little sheet of paper. But I write it with a little pencil and you can't see it in the paper. So I will show you with this marker and on this like little tablet. But I'm real near to end. Dun, 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 It's kind of weird to do this. I'm dun, 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 dun. 6, 7, 6 and 5. 5. So there is the first 20 numbers of the Fibonacci series. See it? They are just beautiful. So this is the Fibonacci sequences, and now I will present you some examples of the Fibonacci serial sequences. No series, because at the end of this video I said Fibonacci series is wrong. The correct way to mention it is Fibonacci succession, no series. So I will show you. Well, my partner will show you little. How can I say it? Like little examples of the Fibonacci series sequences in the real life.
The golden ratio is a special number approximately equal to 1.618. It appears many times in geometry, art, architecture, and other areas. You can calculate it yourself by starting with any number and following these steps. So for example, if your number is 2, then you divide 1 between 2, that's 0.5. Then 0.5 plus 1, it's 1.5. Then you start with the first step again, so that you have 1.5. Then you divide 1 between 1.5. It's equal to 0.6. Then 0.6 plus 1. Then you start over. By dividing a circle into golden proportions, where the ratio of the arc is length is equal to the golden ratio, we find the angle of the arcs to be 137.5 degrees. In fact, this is the angle at which adjacent leaves were positioned around the stem. This phenomenon is observed in many types of plants. For example, the leaves on this plant form a spiral, which if you apply a golden ratio to a circle, we can see how this plant exhibits Fibonacci patterns. The purpose of this having a spiral is to permit optimum exposure to sunlight to each leaf.
Also, we can find the Fibonacci golden number of the Fibonacci sequences in our hand by seeing how the hand is growing by adding this bone to this bone, and then it starts to grow all of the hand and things like that. And also with the human body. The human body starts to grow by adding one thing with another thing, and well, it's so long to explain and I really don't get it at all, but you can also find it. Well, the conclusion that the mates and me have is that the Fibonacci series and the Fibonacci like golden number, it's so important for the humanity. Why? Because it's like the beginning or the little part of for the humans to know the real secret of the universe, of how it is, of how it works, and how well and why. No, well, yes, how it is like formed and from where do we come from. So that's all. Thanks for your attention. See you later.